Hey guys, this is Mrs. Fry. Happy Friday, and we're going to be learning some more about the quadratic formula today. As you can see, I have a graph here, and on this graph I have a very basic parabola shape. And this parabola does not intersect the x-axis or the y-axis. So that means it does not have any x-intercepts or roots, and well, eventually it would have a y-intercept if we would keep drawing going on and on forever, but it's never ever going to have an x-intercept. So basically what that means is there's not going to be a solution. So we would say this has imaginary roots. So whenever I would go to work out this problem and plug it into my quadratic formula, we're going to have complex numbers, which are imaginary numbers. So let's go ahead and take a look at that, okay? So here's our quadratic formula that we learned about yesterday. X equals negative b plus or minus the square root of b squared minus 4ac over 2a. Okay, so I've got two examples for you here, and here's my first one. 3x squared plus 5x plus 4. Okay, so the first thing I'm going to do is I'm going to write down, that a equals 3, b equals 5, and c equals 4, because this is the standard form of a quadratic equation, ax squared plus bx plus c. So now I can plug this into my formula. X equals negative 5 plus or minus the square root 5 squared minus 4 times 3 times 4, and that's all over 2 times 3. Now we're just going to work this out. So x equals negative 5 plus or minus the square root of 25, that's 5 squared, 25, and then we'd have to do negative 4 times 3 times 4, so that would be negative 48, and that's all over 2 times 3, which is 6. Okay, so this is a huge indicator to me that we're going to have imaginary roots or a complex number situation here, because whenever I subtract what's under the radical, 25 minus 48, I end up with a negative number. Okay, so I'm going to just write it off to the side here. Negative 5 plus or minus the square root of, and then 25 minus 48 is negative 23. And that's over 6. Okay, so there's not a whole lot that we can do with the square root of negative 23, but the one thing that I can do is I can take out that negative. Remember, just a little note here, that the square root of negative 1 equals I. So I can take out that negative number and make this I rad 23. So for my solution, I'm going to write it like this. In braces, negative 5 plus or minus I rad 23, and that's all over 6. Okay, so that's the solution. That's all we can do with that, because the square root of 23, it doesn't factor down anymore. It will not simplify any farther. Now let's do another example. If I have x squared minus 4x plus 13, this would be a equals 1, b equals negative 4, and c equals 13. So again, just like with the last one, I'm going to plug this into my formula and simplify. So it'll look like this. X equals negative 4 plus or minus the square root of negative 4 squared minus 4 times 1 times 13 all over 2 times 1. Okay, so the double negative 4, that makes that positive 4 plus or minus the square root of negative 4 squared. Remember, a negative squared is going to equal a positive, because that's negative 4 times negative 4, which is 16. Then we have negative 4 times 1 times 13, which is negative 52. And that's all over 2 times 1, which is 2. Okay, so again, this is a huge indicator right here that we're going to have complex solutions because 16 minus 52 is going to equal a negative number. And remember, whenever you take the square root of a negative number, it ends up becoming imaginary. So let's go ahead and do that next step. X equals 4 plus or minus the square root of 16 minus 52, which is negative 36, and that's all over 2. Okay, now for this problem, because 36 is a perfect square, I can actually take the square root of negative 36, and it's going to look like this. X equals 4 plus or minus 6i, and that's because the square root of 36 is 6, and the square root of negative 1 is I, and that's all over 2. Now, we can split this into 2 different parts from here. I think this is how I'm going to write it. I'm just going to do 2 different parts, one for the plus and one for the minus. So we've got 4 plus 6i over 2. Oops. And then we have 4 minus 6i over 2. So both of these can be reduced. 4 divided by 2 is 2. Oops, I don't know why that keeps doing that. So that's 2 plus 6i divided by 2, which is 3i. Then I'm going to put commas here. Comma, 4 divided by 2 is 2. And then 6i divided by 2 would be minus 3i. Okay? So there's my 2 answers, 2 plus 3i and 2 minus 3i. We have a real part and an imaginary part, so I can't actually add or subtract those together. Let's just put this back together in braces. 2 plus or minus 3i. I guess I really didn't need to split that up if I didn't want to. But anyways, that would be our final solution. So let's take a look at your homework problem. I've just got one problem for you to do for homework. You're going to use the quadratic formula to solve the following equation. X squared plus 4x plus 29 equals 0. And yes, there will be complex solutions for this. I want you to text your answers on Remind and have a great weekend.